So welcome everybody. This is the webinar on the tools for design and sustainability from VentureWell. And the goal here is to give you folks the tools to integrate sustainability into your classes, whether they be dedicated classes on green design, engineering, or business, or whether they be normal core classes. And because VentureWell's mission is to encourage entrepreneurship, this is the particular slant is on new businesses or things like that, but actually these tools are relevant to anything. In fact, they come from a class where I do green redesigns of existing products for companies. Before we get started, actually, I'd like to do a quick poll from everyone on what your experience is with sustainability, so that I can target this talk more to you. And in addition to me, we have our tech support folks helping out. And so if you have any questions, just direct them to Michael, and there's a little chat box where you can ask questions, where you should see there's actually a questions field in the GoToWebinar control panel, and you can use that both for questions that you have in the content of the class, or for technical questions for Michael. But we are going to be spending probably 30 minutes or so with me giving a tour of the site. And so that's more of a, just me talking, but I'd really not like to have the entire hour be that. I'd really like to have it be more interactive, and so that's why we want no more than 30 minutes of me straight talking. And so if you have questions about things, just jump right on in. And by default, when you join, you're all muted, just because we don't want the background noise of whatever dog's barking, whatever's going on in the background. But if you do have a question, feel free to just unmute yourself and then ask that question and then remute yourself. And like I said, if you have any problems with that technically, you can also use the questions field in the GoToWebinar. But so, like I said, before we start, let's do a quick poll to see what you folks are coming in with. So please, everyone, fill this out. You should be seeing on your screen this poll asking, what subject do you teach? And Michael, has everyone sent that in? So, okay, so it looks like it's a pretty even split between business engineering, product design, and more science people than I was expecting, and other. So that's great. We will try to make this a little more broad, and I'll try to make a point of mentioning stuff that's relevant to general science classes as well. Cool. So I think we're done with that, Michael. Okay. And so starting out here, and actually before we start, introducing myself. So I'm Jeremy Faludi, and I teach engineering at Dartmouth, and I specialize in green product design. And actually before coming to Dartmouth, I've only been here a year. Before that, I taught green product design at Stanford and Minneapolis College of Art and Design and various other places. I've contributed to about 6 books on sustainability, including Worldchanging, A User's Guide to the 21st Century. And I designed the first version of AskNature.org, the biomimicry database online, which many of you may have seen. And then I've done other web-based educational content on green design, like the Autodesk Sustainability Workshop and Cradle to Cradle Products Innovation Institute, some of their online resources for teaching how to design for Cradle to Cradle, things like that. But so to get started, VentureWell, like I said, is a group that encourages entrepreneurship in engineering students and other students. And all the stuff that we're talking about is on their website. So they have, this is just their main website, venturewell.org, and then from the top menu here, there is a lot of stuff, lots of resources that you can get to. One of them is Inventing Green Toolkits, which is not what we're talking about today, but is also related. It's more of an intro, so it's a simpler, higher level introduction to sustainability in invention, and so that's design and engineering and business. And so if the stuff that we talk about today looks a little technical and scary to you, you can start with Inventing Green. And also they have a little more detail on the business side, like they have the Presidio Sustainability Booster overlay for business model canvas. And then there's other resources for inventors on entrepreneurship, but what we're looking at is all this tools for design and sustainability. And this shouldn't be too scary and technical for you. So this is a class that I've taught various versions of at different places. I've taught it at art schools for undergraduates studying product design. I've also taught it at master's level for engineering students at Stanford, and taught bits of it at Berkeley as well. And so it should be universally applicable across different levels. It's just a question of what level of work do you expect out of your students as a result of these exercises. So this is the main page that you start out on, and it's just the introductory, telling you what you can find here. It's telling you that for each topic, there's some content that you can read or watch videos on. And then there's exercises to actually do. So everything here we have exercises on. And this is the key part that makes it different from a lot of other stuff that you'll find online. There's lots of online resources for teaching sustainability, but most of them are just media to read or watch, including most of the stuff that I've done before as well. And so this actually has things that you can use either as homework or as in-class exercises or both. And then to give you an idea what to expect out of these exercises, we have examples for everything, which is stuff that my actual students have done in past years for these actual assignments. And the general layout here is whole system mapping. That is a green design method that kind of unifies all the rest of this. We'll talk about that more in a minute. And then there are specific sustainability strategies, measuring sustainability, choosing greener materials, reducing material mass or lightweighting, energy effectiveness, etc. And then down at the bottom, there's another one for integrating into classes. So if you are teaching a physics class or a business class or an engineering class, and you don't want to change the entire curriculum, you just want to inject a little bit of sustainability, this is where you can go to figure out what topics here can integrate into that particular kind of class. And we'll talk about all this stuff in more detail, but that's just the overview. And all these links here go to the same place that these links in the left-hand sidebar go to. And so just to start out, there's whole system mapping. So this is where I would recommend you start, but you don't have to. Like I said, this is designed to be random access because I, as a teacher, know how much work it is to design an entire new class or to teach an entire new class, even when someone is handing you the curriculum. And so we want this to be very easily accessible so that you can spend as little time as possible and just drop in little bits as you become comfortable with them and as you want to add more and more depth of sustainability in your class. But whole system mapping is a design method that I came up with in 2010 for the Autodesk Sustainability Workshop. And you'll see here, this is the content page, and you can see there's a little bit of text, and there is telling you the goal of this right off the top. It's to define the problem that you're solving for by looking at the whole system, and then setting your priorities, ideating solutions, and then checking your solutions against your priorities. And so there's this video that you can watch, and there's also a PDF that is a quick reference guide. Some of these things have these quick reference guide PDFs, so you can see it's just a little one-pager that you can use, and you can print this out or just have it for reference. You could use this instead of the video if you want, or use it live in slides in a lecture that you give, however you want to do it. And then down at the bottom, as with every page, you can see there's a link to the exercise on whole system mapping and an example. So if we click on the exercise, it will take us to that page, and you can see that over on the left-hand sidebar, it's highlighting where we are. So this is exactly the same place that we would have gone if we had clicked in the left-hand sidebar. And if we scroll to the bottom of this, again, you'll see a link to examples, and that takes you to exactly the same place that you would get to if you click in the sidebar here, going to examples. And so here we've got a couple different examples, and like I said, this is student work. So if we click on this, you can see it's this PDF where it actually, the first page is starting out with the grading comments that I gave to this team, saying what they did well and what they could use work on. And then here is the system map that they made, and the various other text, which is the assignment here. So this is the exercise for whole system mapping. And yeah, and here's another team that was doing a different project for a different company. And then down at the bottom here, it links back to the content, the content here and the exercise here. So you can get to everything in multiple ways, either with the links at the bottom of the page or through the sidebar. And just to give you an idea what this is, so whole system mapping, this is the exercise, and actually with all exercises here, you'll see that there's a time estimate, and that is for the entire exercise. And if it's a multi-step exercise, like this one, it says it's a 4-step thing. And so you'll see each individual step has its own time estimate. So again, if you want to do this in class, or if you're assigning it as homework and you have some idea how much work you're giving people, and you scroll down, step 2 is a time estimate, etc. And also when you get to the end of each exercise, you'll see this checklist for self-assessment, and that is basically the grading rubric. And so you as an instructor can use it for grading, and because this website is just free for anyone to use, it's a way that teams can evaluate themselves as well. So just to give you a quick run through for this particular exercise for whole system mapping, like I said, it's a 4-step process, and we're not going to go through the whole thing because it takes at least an hour or two to do the thing properly. But basically, step one is to try to create a whole system, create a map of your whole system, because the whole purpose of this design method is that systems thinking is widely acknowledged to be a key competency for sustainable design or sustainable engineering. But systems thinking is hard, and it's really hard for people to hold an entire system in their head at once. You know, it's like trying to memorize a 20-digit number or something. It's just not what human brains are built for. And there are various kinds of system analysis, like Donella Meadows' system dynamics, where you create stocks and flows and these intricate diagrams of how things depend on each other. And that's all great, but it's a little too much for a lot of projects, both in industry and in education. And so the goal here is to create sort of the simplest version of a visual map of a product system. And so this includes all the parts of the product. So this is a system map of a refrigerator. And if you look closely, you can see all the parts of the refrigerator: insulation, the two chambers, the cooling coils, and the compressor, and the heat exchanger coils. And then you have the whole life cycle of the product: raw material extraction, manufacturing, transportation, the use phase and end of life. And then you also have the user interaction. You know, how does the user interact with this? So in the case of a refrigerator, you've got the little person here with a carrot, and so they are interacting with the refrigerator by opening up the door and sticking food in or taking food out. And then the final thing that you have in a system map is you always want what other products or infrastructure are used along with your product. So in the case of a refrigerator, it's food. You know, if you don't have any food, there's no point in a refrigerator. And this is one of the ways that this system mapping is getting you to think more broadly, because there are other ways to preserve food rather than just using a refrigerator. So it gets you thinking about that bigger context. So you draw this whole system map, and if you're doing this in person as an exercise, I recommend having people use Post-it notes so you can move stuff around. And then step two, you set priorities for green redesign. And you can do this based on life cycle assessment, LCA, which we'll talk about more in a minute, or you can use other ways of measuring sustainability. So it specifically links to Cradle or EPEAT, which we'll see more of in a second. And if you don't want to teach people LCA or these other things before you do whole system mapping, you can just give them a rough estimate to work on. This is a, you know, if we sort of make this image larger here, you can see that it is 4 different graphs of basically rough LCAs of 4 different kinds of product. So a refrigerator is a large electrical device, so you can see that that energy use is the main impact here, as opposed to the materials or transportation or landfill. And then, so that gives you your priorities for sustainability, and you want to combine that with business priorities, such as price or necessary features or things like that. And then once you have your priorities, you brainstorm solutions, and you use the normal rules of brainstorming, but then you also brainstorm on the system map so you can see where you have ideas and where you don't have ideas. And the goal of this is to give you a more thorough brainstorm by showing you you need to have more ideas over here. You know, here in blue, you can see we've got lots of ideas for the center thing. We have no ideas for raw materials. We have no ideas for what happens at the end of life. We have no ideas for what the energy source is. And so you need to keep having ideas until you have ideas for everything on the map. And then the other part of the brainstorming is that you want to have ideas that eliminate parts of the system, either physical components or steps in the process. So you see all these ideas up here: salting food, canning food, drying food. Those are all eliminating the entire refrigerator. And so those are much more radical ideas than just let's make a refrigerator with more insulation. And so that's one of the big goals of this design method, is to not just be giving you ideas for sustainability, but also be giving you ideas for product innovation that improve quality and or features or aesthetics or things like that. And then, so you have lots of ideas, and then you need to choose what your favorites are. And you can do this decision making in different ways, but this exercise recommends that you do a decision matrix where you have scores for your different design priorities: your top priority, your second priority, your third priority, and then you have your favorite, let's say your top 5 design ideas that you put in, and then you score them. And yeah, and then you've got the checklist for self-assessment at the end. And that's it for whole system mapping. And so that just takes you through, and again, if you click on the examples here, you can see, it's taking a second to load here. Oh, it was so much faster before. Okay. So you can see this was a team that was doing a, this is a redesign of a refrigerator. And so you can see their system map with all the different parts of the fridge and the raw materials, manufacturing, transport, the user interaction, the energy use, et cetera, and you can see their design priorities. So they said their top priority was reducing the energy impacts, and they also had a second sustainability one, but then they had these business priorities as well, So consumer adoption was one of their priorities as well. And then they actually did a full LCA of their fridge, and they ran 9 different scenarios to see what would happen. So these are the 9 scenarios that they ran, and they estimated the impacts of each one. And then they made a decision matrix with these different ideas and how they scored. And then they chose a favorite design idea, which was making a fridge that is more like drawers. So you have all these different individual compartments so that you're not losing all the nice cold air out of the entire fridge. You're just using these little drawers. And and so that's just an overview of that. And then measuring sustainability, there are actually 3 different ways of measuring sustainability that we talked about here. And this gives an overview of what the different things are good for. Again, links to everything down here, but you can also click over on the sidebar. So with life cycle assessment, for example, we have a quick explanation of what it is and some examples of these graphs. And then there's a whole multi-page long PDF that's an introduction to it, and you can get more detail, how to set functional units and scoping and all that. And we've got links to Sustainable Minds LCA software, I usually recommend this for students who are new at things because it's the easiest user interface to get people started on. But you can also use more serious LCA software like CinePro or Gabby, etc. And then, oh, and also another nice thing about Sustainable Minds is that it's cheap. So first of all, it has a free trial period that is, I think, 10 days or 2 weeks or something. And then its student price is it's either like $10 a month or $40 a month, something like that. But it's much cheaper than a textbook is for a semester-long class, and teams of students can share a single account because it's actually better for them convenience-wise. Because if you're doing multiple scenarios, you'll want multiple copies of the same LCA model, and you can have different team members do different scenarios, and they can all just share one account for convenience. And then there's a link to Ocala Practitioner here. I saw that Philip White, who's one of the authors of this, was one of the folks who signed up for the webinar here. So Philip, welcome if you're online. I can't see who's online, but yeah, and the Ocala guide is actually a whole course in green design all by itself, and I recommend it. The reason that it's linked to here specifically is because one of the things it gives you is these lookup tables. So it's just this paper printed pamphlet, but it has lookup tables of LCA data that you can just type into Excel and do your own math to figure out the impacts of things. And then this other link here, Equalizer, that is also a downloadable PDF that is just lookup tables of LCA data, and then you can do your own math in Excel. And so again, there's an exercise here. So if we click on the exercise, it takes you through, and again, it's got time estimates and says what the goal of the project is. And like I said, the way that I taught this class is I would have student teams do green redesigns of real products for real companies. So I would have companies mail a physical unit of their product, which the students would tear apart, and they would weigh all the different bits to find out, oh, there's 20 grams of polystyrene, and there's 50 grams of aluminum and 10 grams of circuit board and blah, 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 blah. And it uses so many watts of power. That data they would generally get from the company. And so you can enter all that in here, but if you don't want to do that, because that's a lot of work, if you just want to have this as like a little single drop-in exercise for people, then I also have a PDF for doing this on a common refrigerator. And so there's this PDF that it gives you the full bill of materials, tells you what the weights are of everything, and what the materials are, and the manufacturing processes, and tells you what the lifetime of the refrigerator is, what the energy use is, what the transportation is, and the end of life scenario. So this is a much easier just drop-in exercise for people. And actually, even when you are doing a project class where they're doing LCAs of a real product, or of a product that they're making up, I actually still recommend starting out with this refrigerator exercise, just because most students, particularly design students or folks that are less technical, not engineers, also business students, most people do LCA wrong the first time. And so it's nice for you as an instructor to have something that you already have the right answers for, and that you can, and just makes it easier to grade, so that you can just look at what everybody did for the refrigerator, and you can say, okay, no, you put in the wrong energy because you weren't thinking about the functional units properly, or blah 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 blah, and then they will have a better understanding of how to do LCA before they do it on their product, which is, some custom product that you've never seen before, and so that's harder for you to grade. And once again, there's the checklist for self-assessment at the end, and you can also use this as your grading rubric. And again, PDF example. We've got a couple different examples here. So here's one, and this is, so this was of a piece of furniture for a company, and and these are results from Sustainable Minds software. And okay, so that was it for life cycle assessment. And LCA is not always the best way to measure sustainability. It depends on what you're doing. And so I also have two different certification scorecards here. There's Cradle certification and EPEAT certification. And generally, Cradle is good for simple products like furniture or clothing or something where there's not that many different parts. And if it's electronics, then EPEAT certification is better, because Cradle requires you to basically assess all of the materials down to, I think it's 0.001 parts per million, and electronics are just too complicated for that, and most supply chains are so opaque that even the manufacturer won't have that data, or rather your client won't have that data, because the upstream manufacturers are not very transparent about it. But anyway, so for Cradle to Cradle here, you've got links to some of the tutorial videos on the Cradle to Cradle site, so you can go there and see all that. And then you have a PDF summary describing what the entire Cradle to Cradle certification points are. So it gives you the full details on everything. And then there is also, once we get to the exercise, so we click on the exercise here, and it takes you through how to do this. And basically what it does is it gives you a downloadable spreadsheet, an Excel file, that is the Cradle to Cradle scorecard. It's just a checklist of which points you got and which points you didn't get. And then you can use that PDF that we were looking at just a second ago to decide whether you got that point or not for each point. And then this just takes you through that, and it suggests that for each point you do an optimistic and a pessimistic version, because a lot of these things the students won't know whether they get the point or not. And so you do the optimistic version where they do get the point, and a pessimistic version where they don't get the point, and they can see how that all shakes out in the end. And they can end up with the recommendations for their company, or for their own product if they're doing their own product. And again, the checklist for self-assessment at the end, grading rubric, and EPEAT certification, same thing. And we just jump to the exercise. It's the exact same format, basically. Once again, there's a downloadable Excel file that is a template, and you use that. And that is it for that. And then greener materials. This also has a bunch of stuff. So it has an overview of of things, and um, and and actually also just to give you an example of these videos. So all these videos that you're seeing here were from the Autodesk Sustainability Workshop. And that is something that unfortunately Autodesk came under new management about a year ago, and so they stopped supporting the Sustainability Workshop, and so it's not up anymore. The videos are all on YouTube, so you can get them. They're just a bit harder to find on there, and so all the product design conceptual videos are here in this new VentureWell site. The videos on how to execute things in software are not on here. Those are on YouTube. And the green building videos and text is not on here. The videos are on YouTube. The text stuff is not available, but we're working on getting an archive of that posted. But just to give you an example of these videos here, there's usually a series of videos, and the first one will always be an introductory video, and the person narrating that is Dawn Danby. And I'll just give you a quick example. We'll just play like a minute of one of these videos, and you can either play it here in the window, or you can go directly to YouTube. You know, that lets you see it in full screen.
Today's engineers and designers have more options than ever when choosing more sustainable materials. But what makes something green? Well, a good material is abundant and non-toxic. It doesn't require a lot of energy and other resources to make and use. It has the right physical properties for its function. It also meets or exceeds regulations, has good end-of-life options, and doesn't drive up costs. That's a lot to consider, and it can get even more complicated than that.
So that's just a quick example of these intro videos are always giving you the overview, and they're saying why it's important and giving you the problem statement. And then the following videos are the ones that give you solutions of what to do about this particular issue. So giving you design strategies or tactics. And so just a quick example of one of those. And I'll
but now,
skip to the middle here.
Listed too quickly and becoming endangered. When using wood, try to find sources that are certified as sustainably harvested. Materials like bamboo are called rapidly renewable because they can be regrown and harvested fast enough to keep up with heavy demand. This often makes them a good choice. You also need to look at the energy and resources that go into gathering material and refining it into a useful form. It takes about 40 megajoules of energy to mine and manufacture 1 kilo of virgin steel, but it takes nearly 6 times more energy to produce virgin aluminum. And when either material is processed, like rolling or extruding, even more energy is consumed. Energy consumed this way is called embodied energy. Usually the material's carbon footprint is directly proportional to its embodied energy. But it's not just energy that gets embodied in a product. Other resources like water are embodied in the same way.
Yeah, and so you can get the idea there. And so on the greener materials page, we have some of these videos, and then another handy thing that we have here is these chooser charts. So if you want to choose a greener plastic, it gives you a very simple continuum of better to worse. So the best plastics are leftover waste plastics, and particularly in schools, there's often scrap sitting around. And then bioplastics, and then silicone and acrylic kind of in the middle, epoxies, polycarbonate, and PVC down at the worst end. And you'll see that there are also little icons here for the the uses that people might be putting these plastics to. Excuse me. So if you want something for laser cutting, you look for that icon like PLA, PHA, polypropylene, acrylic, or if you want things that are strong, acrylic, ABS, etc. And so we've got these for plastics and wood and metal, and then another one that's related for power supplies as well. And we've also got links to other things that have, it's linking you back to LCA sources like Ocala and Equalizer, and for apparel, the Sustainable Apparel Coalition's Material Sustainability Index, etc. And then it's got two exercises here for greener materials. One is finding greener materials. One is swapping in greener materials. So for finding greener materials, we've got all this content on how to find greener materials. So we've got a bunch of books on green materials. Materials in the Environment by Michael Ashby. It's probably the most famous one. And we've got online catalogs of green materials. So like Cradle to Cradle, they have an online catalog of all the products and materials that are certified Cradle to Cradle. And so you can find a bunch of great green materials there. FSC certification for sustainably harvested wood. SA 8000 for social sustainability. And then there's databases and analysis software. So there's CES Selector software, again by Michael Ashby, is probably the most widely known one. LCA software, you can just poke through the material databases of LCA software to find ones with low impacts. Or there are fun websites like Transmaterial and Material Connection that are all about finding exotic materials, and lots of other resources here. And there's chemical toxicity databases as well. So Pharos is one that I really recommend, and the Cradle banned list of chemicals, etc. And so the exercise here is basically to go out and do some research and find some green materials and get price quotes on them and say why they might be good for your product. And so there's a quick example of that. Here is a fun one for people that were choosing a material for, what was it? I believe this was a jacket for the North Face. Yes, yeah, it was. So it's got various things that they found online and what they thought the advantages were, and price quotes that they got. And then swapping in greener materials. This is the bigger picture, more thorough brainstorming, where you go through the whole system map that you came up with earlier, and you do brainstorms that are just material related. So again, an example of this would be, this is a piece of furniture here, and so you can see they've got this brainstorm where they're making a list of, for this particular part, they had 5 ideas. For this other part, they had another 5 ideas. For this part over here, they had 15 ideas. And so this is a nice thorough brainstorm for finding greener materials all across the entire product. And then once again, part of this exercise is to make a decision as to what your best option is, what will make the biggest difference. And so here they chose bamboo to replace steel. That was one of their favorite ones. And then bioplastic to replace these normal petroleum plastic dividers was one of their other top ideas. And they did LCAs of these different scenarios to figure out which ones would cause the best impacts, rather than just assuming that because they chose bamboo for something that it would automatically be better. It's a way of avoiding greenwashing by doing actual analysis to see how much better your product will be. And just in the interest of time here, we'll skip through some of this stuff. Lightweighting, this is reducing material use. Design for lifetime and sharing. So this is everything from designing for durability and longer life to designing for repair or upgrade or recyclability or compost. And so we've got a bunch of videos on that, and another quick reference guide. So this is, again, something that you could just post up in the classroom somewhere, or assign as a homework, have 10 ideas for this design for repair strategy, have another 10 ideas for this design for repair strategy, have 10 ideas for this design for recycling strategy, have 10 ideas for this design for remanufacturing strategy, etc. And another useful thing on this page is designing for product service systems. So this is a little taxonomy of different ways that you can turn a product into a service. Whether you're turning a car from, a product, which is all the way over on the left here, to this column where a car is becoming a taxi or Lyft or Uber, or product leasing in the middle, etc. And again, we've got activities on that. And energy effectiveness. This is one of the places that'll be more applicable to a general science class, like a general physics class, because the videos on reducing energy losses are straight up physics things. So like one of the first ones for energy losses in design is reducing friction. And so that is a video all about principles of friction, what the math is for friction, and then some suggestions for how to reduce friction. And same thing for heat transfer. That video is showing you some of the math of heat transfer and suggestions for how to prevent heat transfer when you don't want it. And then changing lifestyles. This one is about persuasive design. So how can you change people's behavior so that they live greener lifestyles? And so there's an example on this. And and there's also, in addition to the videos, there's a nice quick reference guide on this as well. So changing behavior is mostly about increasing people's ability and increasing their motivation. And so you can have a brainstorm where they need 10 ideas on this motivation strategy, 10 ideas on this motivation strategy, etc. And so here we again have two exercises. And so we've got the exercise on coming up with ideas for persuasive design, and that's great. But then another one that I think is really important for persuasive design, and that I think you should always do in combination with the other exercise, is evil persuasion. You have to think about the potential unintended consequences of what your design will do. And so the exercise here is basically, and this is really quick and simple, it's like 10 minutes to 40 minutes. And then with the write-up, it's 15 minutes to an hour. And it's basically look at your favorite ideas from the previous exercise, the persuasive design brainstorm, and think of how they can go horribly wrong. think how they can actually make people's lives miserable rather than better. And that's just a way to prevent people from running into unintended consequences. So that is it for the content on here. And then just the last thing that I wanted to mention is this page on integrating into classes. It has a list of mechanical engineering or physics classes that you might want to integrate into, industrial design or product design classes that you might want to integrate into, and business classes that you might want to integrate into. And each one of these is a searchable list, so you can say, what if I am teaching strategy? And you can see that it filtered that list so that it's just talking about courses on strategy. And you can see that if it's sort of business strategy, competitive corporate strategy, whole system mapping is something that you can use, and these ways of measuring sustainability is, again, content that you can look at. And then particular exercises that are relevant are the whole system mapping exercise, the LCA exercise, the cradle-cradle exercise, and the EPEAT exercise. And then, similarly for all these other things as well. And so, for instance, if you're teaching a physics class, some of these energy effectiveness videos like friction would be relevant, and also the exercise on calculating energy priorities for reducing energy use. Or if you're doing a statics class in mechanical engineering, the lightweighting videos are relevant to that, and you can use the exercise on that. Fluid mechanics, we've got a video on that, et cetera, et cetera. And then for product design, pretty much all of this stuff is relevant, but one of the most common things that people want is material choices. So you could do the materials videos and the two different materials exercises. So, okay, so that has gone through. I kept waiting for people to interrupt with questions, but didn't hear any. So do people have questions now?
Jeremy, I have a question.
Great.
When measuring sustainability, do you have recommendations on which approach to use first?
The approach to use first will depend on what you're doing. I would say the number one filter to think about is whether you're concerned with social impacts or whether you're focusing on environmental impacts. If you're just doing environmental impacts, then I would say life cycle assessment, because it doesn't measure social stuff. But both Cradle to Cradle and EPEAT have at least some consideration for social impacts. So that's one criterion. And then the other criterion is what kind of students do you have? If you have more technical students, then they will have an easier time with LCA. If you have less technical students, they'll have an easier time with the checklists of Cradle, Cradle, and EPEAT. But in general, I recommend LCA even for non-technical people, because it's a really good exercise in thinking about what all the different kinds of environmental impacts are out there, and how to balance those impacts against each other. And it also, I think, is the sort of simplest demonstration of priorities in terms of, you can look at any one of these graphs and say, okay, for this product type, it's the materials and manufacturing that's the biggest impact, and so that's my top priority. Whereas for clothing that gets washed a lot, it's harder to say what your top priority is. Maybe it's the materials and manufacturing, maybe it's the energy use, but you should really pay attention to both of those things. Do we have other questions?
Jeremy, one other question. If I can only include 1 or 2 tools or resources into my course, which do you recommend as a top priority?
Okay, another good question. So it once again depends on what kind of class you're teaching, and so I would check the integrating into classes section, and look up by what kind of class you're teaching. But in general, I would say if you had to choose any of these, I would probably do the whole system mapping design method, because that can be a fairly universal thing. Or I should say, if you've already got a dedicated sustainability class, green design class, green engineering class, green business class, and you can only include one thing from here, I would use the whole system mapping method, because it is a fairly universal process that you can use on anything. But if you are doing a different kind of class, then I would probably say measuring sustainability, whether that be LCA or one of these other things, would be the top priority, because all these different strategies of like choosing materials and lightweighting and design for lifetime and all that, they are all strategies to achieve improvement in sustainability. And you can also achieve improvements in sustainability by just randomly having ideas. And I think the most important thing is to know what your goals are in how you're improving sustainability. So if you measure the environmental impacts or the total sustainability impacts of your product, that will tell you what your biggest problems are. And then you can use your own brainstorming to find solutions to those problems, or you can use these more specific techniques and tricks as they're applicable. And that's the sort of thing that students can find on their own if they need to. And different student projects could have very different priorities. Like we were just saying in LCA, maybe energy use is the most important for a refrigerator, and the materials is most important for furniture. And so those two different teams can, on their own time, look up the stuff in energy effectiveness or greener materials, and find their own solutions.
Jeremy, we have one final question. We have about 2 minutes left. So the question is, do you have an element that calls out alternative assessment?
Oh, you mean for toxicity scorecard alternatives assessment?
They didn't specify, but I believe so.
Okay. I do not explicitly have that in here. What the closest that I get here is that most of these exercises, like doing the whole system mapping exercise, when you do this exercise, it'll ask you to have a lot of ideas and then to score them by which ones hit your priorities the best. And that same thing is true for these other activities. I would say most alternatives assessments would be pretty similar to the either finding greener materials or swapping in greener materials exercise. And so like with the swapping in greener materials exercise, that actually, yeah, I'll show one of the examples again. So you have a brainstorm where you're thinking of lots of different material ideas. So here they put all these colored dots for where their ideas were coming from. So they had this big list of all these, whatever it is, 20 different ideas, 30 ideas, and then they scored them using, or I guess here they're not showing an estimated life cycle assessment of each one, but I guess it was this other example where, yeah, they did some LCAs of their top ideas to see which one would actually create the biggest improvement. And if you're specifically interested in measuring toxicity as a way of measuring sustainability instead of, or in addition to, life cycle assessment or cradle to cradle or EPEAT, then I would say what you can do is you can go to the Greener Materials site and the Finding Greener Materials, and using one of these toxicity libraries like the Pharos library, it can give you green screen data or cradle screening data, so that you can score one material or chemical against another, and then you can use that as your rating system instead of LCA or cradle to cradle or EPEAT, or in addition to it. So I hope that answers the question.
Okay, Jeremy, I think that's it. If you have any final words, thank you again for your time.
Yeah, that's it. Thank you everyone for showing up, and I hope that you find this a good resource with lots of stuff in it, and I'm always welcome to hearing feedback on what you would like more of, or what you think should be different. Yeah, thanks everyone for coming.